which I'm going to share with you, give you a different picture about what makes us different as a customer. So our value propositions are all geared around flexibility, a lot of configuration flexibility, the ability to go high density, the ability to reduce power, and we'll look at how we do that, higher availability, and being able to integrate easy deployment. You can't see it from this picture here, but this is a Yahoo data center. The reason why I know it's a Yahoo data center is because I know this. If I look at the pictures, if you saw it on a bigger picture, all the cabling on all the servers is in purple and yellow. Now that might sound like, why is it in purple and yellow? Because purple and yellow are Yahoo's corporate colors. So when we do a server deployment for Yahoo, they insist on all their cabling done in purple and yellow. So we deliver it, all cabled up, ready to go. Now, no other vendor will go to that level of flexibility. When we deliver systems to McLaren, for example, McLaren F1, McLaren's corporate color is white. So if you go in McLaren's building and their data center, everything in their data center is white. So we deliver completely white cabinets and systems and everything else. Now, it's very interesting because we did an upgrade with McLaren recently, and they asked us to take away an old system, and they wanted to trade in on the system. And we said, well, it's old, it's not got much value, and it's white. So not many people are really going to want it. So we said to McLaren, I'll tell you what, if you get the drivers to autograph the racks, we'll put it on eBay for you. So we actually got them to autograph all the thing, we put it on eBay, and we got more money selling with the autographs than it was worth of the good story. So what makes us different with the rackable servers is we have some fairly unique designs which optimize around power consumption, and I'll talk about that. We have this design to order model. It's very hard for me to explain that. I've got one slide I'll show you later which just shows you a range of things we put in our servers. When you see that, you'll understand what I mean by configure to order. And we try and go for this turnkey deployment where thing arrives already rack stack cabled, that purple yellow cabling or whatever you want, white color, whatever makes it appropriate. So in our configurability, we offer solutions for both Intel and AMD CPUs. We offer a lot of flexibility there. We have this concept of half-depth form factor. And I'll explain what that is. So if you take a normal server, it's about this long. If you take a rackable server, it's about that long. Now, why do you only make it that long? Two major reasons. One is I've only got to move air that distance. That means I need less fans, and it means the temperature difference between the front and back of the server is very different. If you go in a normal data center and you walk behind a rack, you can almost make toast on the heat coming out of the servers. If you walk behind a rackable rack, you'll notice a very different design because the air moves through it so quickly it doesn't get a chance to get hot. So that means you need less cooling in your data center and you need to provide less power. And we'll come back to design order again. So as I said, we have this half-depth form factor. It means I need less fans and the ability to use higher temperature air. So for example, I can actually use air up to 40 degrees C on the front end. I can mount them in any platform, and I have this ability to do practical density. So we can actually mount servers back to back. Because this difference in temperature is so low, I can actually mount one server on the front of the rack, one server on the back of the rack, and just pull the air through the two. Which is quite a nice way to do deployment and get density. It's annoying me, this top of the screen cutting off. But there you go. So one of the things we talk about, we try and look at cutting out power compared to our competition. If I save 10 watts of power, it saves about $100 in power cost over the life of the server. And we'll look at how that means. And what we do is we work very cleverly about picking component choices. You know, we'll pick a lower voltage CPU, we'll pick more lower voltage memory, we'll pick lower voltage hard drives. We'll show you some designs, and we also use the concept of using DC power rather than AC power. Now DC power is very consistent because if you get a DC system, the power delivery is constant. If you get an AC system, the power is much more like that. What that means is if I've got an AC system, then I use typically the same power consumption when it's running at half power as I do when it's running flat out. With a DC, I get a different use. So this is an example of a competitive server. It's an old Dell server, but it gives you an example. If you take the covers off and you open up and count all the fans inside, you'll find there's 19 fans inside the server. And that's because it's got to pull air all this distance through the box. 19 fans, 8 watts of fan, gives you about 152 watts just driving fans. And it's usually very noisy because you've got these little fans that go. If you ever walk in a data center, you'll understand what I mean by that. If you take a rackable design, it's very different. We typically have this smaller design point. With it, I have only 4 fans at the back, each being 9 watts each. You'll notice some really funny things inside the chassis. So you might find, if you lift the cover off, you'll find little bits of cardboard bent around parts of the design. It looks really strange, but what it's actually doing is it's making sure the air here gets pulled right over the processors to keep the processors cool. We do a lot of work with different vendors to design our own motherboards. So quite often we will place components in different ways, so we have memory at the front, CPUs at the back. You okay?
Yeah, we're trying to get the...
It's okay, it's just annoying me really. So when I do this sort of design, this all sounds very good, but let me give you some examples from a real customer. I have some measurements that were taken by one of my customers. They're not my measurements, they're my customer's measurements. And this customer took 4 different servers. Took a Dell server, HP server, an IBM server, and an SGI server. All pretty much identical CPUs. Actually, the IBM server uses lower voltage CPUs, so it should be less power than mine. Memory's about the same, drives are slight differences. And the customer looked at running a web workload. So they had a benchmark they ran on it. How many web pages could they serve out on the platform? And you see a big variation. You wouldn't expect this, but there's a big variation. So the Dell box did 91, we did 90, so about the same. The HP box, even though it's the same configuration, did a lot less performance. Now, why is that? I'll tell you why, because we probably use faster memory than them. We probably optimize our BIOS better than they do, because we do more specialized manufacture. So the performance advantage varies. The big difference you'll notice is in power. Our server came in at 280 watts of power. The Dell box, on the same workload, was over 100 watts more power. HP 22 watts, IBM 32 watts. This is a particularly bad box, by the way, because this is using lower voltage CPUs, and is still using more power than our box. So it's a bit of a dog, in my opinion, as a box. But just to give you a view on what that really means. Now, one of the reasons we're very strong in the internet world is a lot of our customers in the internet world don't have their own data centers. They put their equipment in a co-location center or somebody else's data center. When you do that, you typically pay per rack of equipment. So you buy a rack and you pay for the power separately. And a typical data center will probably provide you with a 16 amp feed, which gives you about 3 kilowatts of power. So here's the Dell R410 from the previous page in our box. You compare the two and the power draw. What it really means is I can put 12 servers a rack in versus 9 for Dell. Okay, doesn't sound like a big deal, only 3 more servers. But if I'm trying to roll out 100 servers, what it actually means I need 3 less racks. If I'm paying per rack, that's real money I'm saving. So 25% better density means on a 3-year cost, I can save almost $100,000 just in rack and power costs. And that's one of the reasons why customers buy our technology. It's the real saving in money, particularly in a co-location scenario. So as I mentioned with this half-depth design, that gives us the ability to mount both sides of a rack. I can put servers on the front, servers on the back. And I can do 2 things. I can either vent out the middle, take air in from both sides and blow it out the top, or I can do a normal straight front to back. And because my temperature variance is so low, I can, if I'm taking in normal data center air at about 25 degrees, when it's coming out of my first server, it's probably about 29 degrees. 29 degrees is still okay for the second server, and it's going to come out around the same temperature a normal server would be. But if you understand what I've done here, I've actually doubled my density. So I've got two servers in the same space of one server, which gives me a lot of benefits in certain environments. We enable you to pick different powers you want. You can have normal AC power, or we can have DC power. With DC power, we use a concept called a rectifier. Explain what a rectifier is. If you've got a laptop, what you normally get with your laptop is you've got a little box which you plug your power cable in, and then it plugs into your laptop. All laptops are DC. That little box is a rectifier. What it does, it converts AC to DC power. So what we do is take that and put it in a rack. Now, two benefits of doing that. So this is my rack. On the top here, what I've done is I reuse rectifiers on the top. So imagine those little power supplies from your laptop. I've just basically put them in the top of my rack. And then in each server, instead of having an AC power supply, I put a card in. Now this is a DC card. It's a solid state card, so there's no moving parts on it. It has about a 2 million hours between any failure on it. It's a solid state card. If you compare that with a normal power supply, it's about 15 to 20 times more reliable than a power supply. So it's very, very reliable. I get a lot of benefits from power saving. The other thing which I do is by using these cards, I take about 40% of the heat out of the server. So actually, it means I don't actually break the drives and memory. Because what normally happens is you've got a lot of heat, disks and memory don't like heat. It's a, if you get a memory DIMM and you warm it up with a thing, it's eventually going to fail. If I take 40% of the heat out, I actually reduce the likelihood of failure and improve my reliability. So it's quite a clever solution. I'm going to show you a few pictures now. I'm going to spend too much time on this. Here's some of our server range. We have a 1U server. It's about this big. It has up to 1 or 2 drives in it, AC or DC power. We have a 2U server, which is our most popular server line. For most vendors, it's a 1U, big full depth 1U. For us, it's a 2U. Why is that? Well, the main reason is because it's a 2U, I can use big fans on the back, which take even less power. I only need 2 of them. They take about 12 watts of power for the fans. I can also use a big heat sink about this deep. Now when I use a heat sink, good news about that, it takes a lot of the heat out. Also with this chassis, I have lots of flexibility. So I can have 4 disk drives and 1 expansion slot, or 10 2.5-inch drives and 5 slots, or sort of 4 and 2, or just 2 drives and lots of expansion. It's all one chassis. So it's got a lot of flexibility on it. Basically what I do is I just have modular components to put in it. We're just about to launch this month a brand new product called the 3000 series. This is a 3U product, and it's basically a 1U server with a load of drives on top of it. And I can have either 12 3.5-inch drives, 24 2.5-inch drives, or 6 or 9 3.5-inch drives, again all with different slots. So I've just taken that concept, the 2U chassis, made it a bit bigger, give myself more drives. Amazon buys these systems by the bucket load. Most of their storage services run on this type of platform. It's a very popular, very flexible server. I have a big box, it's a 4U box, it's a quad socket machine, a 4 CPU machine. But because this machine is this deep, I can do some clever things with it. And one of the things I've done with this product is I put in a new motherboard, which is an overclocking motherboard. So if you take a normal Intel server, the fastest CPU you can get today is 3.3 gigahertz from Intel. By using this motherboard, I can get those CPUs up to 4.3 gigahertz. So I get about 30% more processing power. Now if you're a bank, that's really good news, because you can process transactions much faster. So the banks really like this. The problem is with it, is it's really complex to do, because you need special heat exchangers, you need water cooling, you need big heat sinks. So it's a lot of complex technology to make this work. So we put all this platform in that 4U platform, and I come up with something like this. You see I got a heat sink that literally is about that big. I put a water cooling on top of it, I put some special cooling inside it, and I can fit it into this big chassis. So it gives me a lot of flexibility. This is what we can do differently to other people. We just won a global standard with Deutsche Bank for this platform, for their trading platform, because nobody else can provide them with a 4 gigahertz CPU. So it's a real unique, but as you can imagine, it's quite an engineering effort to make this work. And we did this for a production run of 20 servers. So we're not talking about doing this for 1,000, we do this for small production runs. I've talked a little bit about build to order and design to order. And I'll explain to you a little bit about what that really means. This is a little bit of an eye chart. This is our range of motherboards we're offering with the new Intel CPUs that are coming out in February. As you will see, there are 9, 10 different motherboard designs here. And you'll see in most cases they fit in all different chassis that we have. Now, why do I offer this number of boards? Because I may have a customer that wants something unique. If you want a lot of memory, this motherboard has 24 memory slots, enabling big memory configuration. This motherboard enables you to go with the very fastest CPUs, 150 watt CPUs. A motherboard here that's got 10 gig Ethernet on the motherboard. So rather than have to use an expansion card, I can just use a 10 gig out of the card. So we basically look at what the customer's requirement is, and then we choose the appropriate motherboard that fits. We'll choose the appropriate memory, appropriate drive. So we're almost building you a custom box. But we do all the certification for you in the lab, so when you get it, you know it's going to work first time. That's very different to the other vendors who will just give you a Dell P1758, which comes with 2 CPUs and memory. I can let you choose what you want to put in the box. And we do that for Intel, we do that for AMD motherboards. Slightly smaller range here, but I've got 8 motherboards for AMD. But as you can see, a lot of flexibility what we do here. I only showed you a selection of our chassis, but there are a number. So we have the 1000, which is a 1U, 2005, the 3000. We have a full depth chassis. We have these are new chassis we've got coming out. 3U chassis, 2U chassis. What motherboards they support and what expansion slot they support with them. So we have a lot of flexibility. You take all that design point in there. We give a very different approach to our customers to a normal vendor would do. Now, as I said, if you're going to run email, it's probably not that interesting for you. If you're going to run more complex workloads, this is a lot more interesting to our customer base. And as we say, we try and deploy things as easy as possible. This is a genuine picture, by the way. We deliver things in cabinets, in crates. So all the work is done in factory. We literally deliver it. You take the brake off, you wheel it in, you plug it in, and away you go. If you don't want to buy it cabinet-wise, you've already got cabinets and racks. And we have another concept called the server coffin. Right? And it really is what it comes like a big coffin, and in it you'll find slots. In the slot is a server. So when you deliver it, if you're going to order 25, 30 servers, just lift the crate lid off, you pull the server out, put it in the rack. Now, why is that a benefit? Well, the number one benefit of it is I haven't got to do all those boxes that the other servers come in. My customer Hives in Netherlands, when we sold them their first systems, they bought 100 servers from me. And they told me, they said, we can deploy about 50 servers a day. We bring in 8 students from the local university, you get them to unpack it and put it in the racks for us. They said, 50 servers, that's not very many, we'd expect to do better than that. They said, oh no, we've done it, we can't do more than 50 servers a day. We delivered our servers in the server coffin, we deployed 100 servers in 2 hours. Because there's no unpacking to do. You don't get 15 copies of the manual. It all just comes right packed. And it might sound like really trivial things, but this makes a real difference when you're trying to get your things deployed quickly. And a lot of people these days obviously don't want to have lots of packaging lying around, because one, it's expensive to have packaging, and 2, from a green point of view, it's not a very good thing to ship 100 boxes around really. So that is our basic design point where we start with a standard sort of pizza box server. If you want to go beyond that, we have a product called Cloud Rack, which takes it beyond this. This is a complete rack at a time level deployment. And it doesn't use servers, it uses trays. And I'll explain what I mean by that in a second. I'm going to skip some of the next couple of slides. And I'm going to show you a couple of pictures. So this is a Cloud Rack cabinet. Servers on the front. You'll notice they look very different to a normal server. on the back you have a cabinet with all the fans built into the cabinet. Now these fans are about this large, and we set them up in groups of 6. 2 master fans, 4 slave fans. And these fans are temperature sensitive fans. So if the air coming through is hot, they speed up. If the air coming through is cool, they don't run very fast. And they're set up so that if you lost 2 fans, the system can still run. We take normal power in, and we convert it inside the rack to DC power. So all the way through the rack is DC power. Here's the front of the rack. You have some networking equipment in the middle, and so on. So what does that really mean? So what I end up with is no longer a server, I end up with a tray. And it literally is a tray. When Rackables first started out, the first servers we did for Google were done on a baking tray. And we put rubber mats on and motherboards, and we built them servers on a baking tray. And it literally was a steel baking tray. So we want back to that type of design here. So here I have 2 servers, and I have 12 disk drives mounted on a tray. The observant ones amongst you will notice there's no fans. The fans are in the cabinet. You'll also notice there's no power supply. We have a blind mate connector, so it connects into a backplane on the cabinet. Now, that takes a lot of the heat out, takes all the fan overload out. On a full rack, I take out about 1 kilowatt of fans compared to normal servers. So if you're buying a rack at a time, you can get very, very big power savings with this platform. The observer will have noticed that if I've only got a blind mate connector, if I want to change a disk drive or something, I've got to pull the tray out. I'm going to lose my power. I'm pulling it out. Now, we've thought of that. So on the front, I've got a little connector on the front here that I basically plug a cable into. So if I'm doing maintenance, I plug a cable into the front, and then what I do is I basically run that cable from there to the tray above. So I basically take tray from the tray above or the tray below. And because it's all DC power, there's no risk. Yeah, it's 12 volt DC, there's no power risk, means it's very easy to maintain, and then when I finish I just push the tray back in, pull the cable up. Makes the maintenance very simple. When you're doing a very large deployment like an Amazon, you can understand why you go for this type of approach. Very low power, very easy to install, very easy to maintain. So beyond that tray, this gives us the flexibility to do some very customized things. So a couple of examples. This is one we did for Amazon, which is 2 servers and 8 drives, 8 big drives, not small drives. This is one we did for eBay, which is 10 drives plus a solid state drive, 1 server on a tray. For Microsoft, we did something even more funky. We cut the tray in half, so you had 2 trays in one, with 4 drives and a motherboard in each one, because they wanted a different deployment. For EMC, EMC has a service called Mosey, which is a backup service. They don't use EMC technology, though EMC will not tell you that, they use our technology. So what we built for them is we built them a disk tray. So it's basically a tray just with 15 disks on it. And then what we do is we connect it with a number of switches to a couple of servers in a rack. But this is an online backup service that when you go home, you plug into your network in the house, it backs up your data for you. A bit like Apple's doing with iCloud. Very similar concept, but it all runs on SGI technology, again in this sort of custom rack design. And we're thinking beyond even this. So you start from the server to the rack. Where do I go beyond the rack? Well, going beyond the rack, I get into the concept what we call a modular data center. And this is really designed about changing your growth. And the way we used to describe this is it's almost like having a very large USB stick I can just plug into a network. When I show you what it looks like, you'll understand what I mean by that. So what we've tried to do is change our unit of growth from a server at a time to a rack at a time to a complete data center at a time. And I literally mean a complete data center. It comes in a cabinet, you plug it in, where you go. And we've actually done these for Microsoft and also for British Telecom and others. At BT in London, we put a data center on the 3rd floor of a building inside a container to do video serving. We have 2 product lines that come out of this. We have a product called Ice Cube, which is a standard ISO container, big steel container. And we have a really funky design called the Ice Cube Air, which doesn't even use any cooling. It just uses external air. So in some countries you can use external air all year round. So we have a project we're working on right now in Finland, up in the north, where their data center, they can actually run on external air with no cooling for 350 days of the year. And for the 15 days when they can't, we use a drip water cooling. It's really clever cooling technology. But you can imagine the power savings you're going to have. I don't need chilled water, I don't need aircon units. I'm just using literally external air. So if I take the first design, the ice cube design, you know, we have a standard, so this is a container with racks in it, with a cooling design in it. In this design, all you do is plug in water, and you plug in power, and you plug in network, and away you go. 8 configurations in a 20-foot or a 40-foot design. If you don't like our designs, you want your own one, we can actually build you a different design. So we did one for the US Army, where they wanted a remote design to put on a battlefield, where they want to have an operator room plus some computing in it. So we've actually built one that's half operator room, half computing, that's fully contained. Beyond that, we have the Ice Cube Air product, which, as you can see, you're taking air in from the outside. I use outside air, I use evaporative cooling, and this is much more of a sort of custom design. You can actually create a complete data center in 2 or 3 days on a concrete slab without having to use a building. Now that's a bit revolutionary. If you go onto YouTube, you will find, you do a search on Ice Cube and SGI, you'll see a lot of videos of us deploying systems in the US, literally on a concrete slab. There really is nothing like this at all on the planet. You have 3 models. They start at 4 racks, going up to bigger than that. You can add cooling. You can use direct air. You can add evaporative cooling. You can add chilled water if you want. You get very, very high efficiency with this. With the evaporative cooling, you literally just use a garden hose and a tap. No chilling, no aircon units, just a garden hose. You plug it in, it uses about 7 litres of water an hour when it's running, but it's just normal water, it's not chilled. And you use about 1% of the water you use by normal chilled water design, and no waste. Now, put that in so you understand what I mean by this. This is a tennis court. I'm sorry it's in feet, it's the American slide, so not in meters, but it's a tennis court size. If you think of a tennis court, here I've got 6 containers. This is a 2 megawatt data center on the size of a tennis court. So think the size of this room pretty much. I've got a 2 megawatt data center. Basically what you do is you're putting in, here are 6 containers, each with a tap connector in. In the middle I've got a sort of fan system that puts the air out, the hot air out. And then what you basically have my racks there. I have a central hot aisle and I have cold aisles either side. So providing literally 60 racks or so, each rack going to about 40 kilowatts of power. When I showed my slide earlier about a normal colo at 3 kilowatts, if you can provide the power, we can cool 40 kilowatts a rack, which means you can put a lot of computer, a lot of storage into this design. Completely revolutionary way to do it. I'm not so sure that people would use this for their mainstream data center too much, but if you want a DR center, disaster recovery center, or anything like that, it's perfect. There are a lot of interest from the oil companies, for example. We have one customer in Kazakhstan, which is Chevron Oil. And Chevron Oil has got their drilling position is 1,200 kilometers away from the nearest airport. And nobody wants to go there because it's literally in the middle of nowhere. They wanted to put a data center in there, so we're working with them right now, putting a containerized solution there. They could basically just lock the doors and leave it as a container on the location. Because when you're that far away from civilization, you're a long way away from where you want to send people to go. But that gives you some of the concept of how you can use this type of technology. So that's all I really had to sort of say to you today. To give our messages out, we're very much focused on this whole concept of technical computing, and that whole concept is starting to get awareness with people, and they're starting to realize that just using a mainstream product may not be what you want. Cloud is obviously a big opportunity for us everywhere, really. We're committed to help our customers solve most of their technical computer challenges. And if you have something that's a little bit strange or unusual, it's perfect to throw at us. And we did a call on a web customer recently in Czech Republic. It's a website. And we talked to them about their web environment, and they were like, yeah, web environment runs pretty well. Don't really want to mess around with that. And we said, well, what else do you do? Well, we've got a search engine, like Google. I said, oh, okay. I said, how about the search engine? They said, oh, search engine, it's a nightmare. The guys who do the search always want to do something different. They want to do some more complex things because they're all big, brainy guys. So they gave us that problem and said, can you come up with a solution for search? And we could build them something that was unique, that basically got the IT guy had a much quieter life because we took the problem away from him. We're focused on expanding our market opportunity to new countries. Romania is a good emerging market for us. I'm delighted to be here. It's my first visit to your country, and it looks a beautiful city, really enjoying it. We're keen to expand our market opportunity with trusted partners like Spearhead. You're going to see us with a lot of demand on our products, and our aim is to be, where possible, a trusted partner and trusted provider to all of our customers and partners. Okay?
Perfect. Thank you.
Under the lights, it's a bit warm.
It is a bit warm, yeah, I know. Literally on the spot. Cred că singurul lucru care pot spune este wow. Asta este a doua sau a treia oară când văd aceeași prezentare. De fiecare dată simt de parcă mi se deschid noi oportunități. Este un vendor atât de unic, atât de dedicat soluțiilor specifice clientului. Nu există un part number care se aplică pentru toți clienții sau un server sau un model de centru de date. Totul este customizat la nevoile clientului, la cerințele clientului. Și asta sper că spune multe, cum a spus și pentru mine. Am văzut diferența de curând cu clienții noștri care au optat pentru soluții SGI și este o diferență enormă. Să ne vină serverul cablat, etichetat, cu sistem de operare deja instalat, adrese IP deja configurate. Noi nu trebuie să facem decât să-l luăm și să-l băgăm într-un rack sau un centru de date și să-i dăm drumul. Valoarea este enormă ale produselor. Aș recomanda să facem o pauză de 15 minute, să mai aerisim puțin camera.
Da, e cald, e foarte.
Și după aceea, încă o scurtă prezentare despre compania noastră și v-aș spune sau aș detalia oportunitățile pe care le-am identificat noi, punctual pe piața noastră, ce putem face, unde putem lucra împreună. Mulțumim frumos! Thank you, Rod.
Thank you. Thank you.
Suppose we do a 15-minute break, try and cool down.
Warm.
Yeah, it's very warm.
Well, the lights don't help.
We'll turn them off.
No, but it's very warm.
We should turn them off for you.